The last 19 problems. The first 20 problems were easy peasy lemon squeezy. The last 19 do get a little more difficult. All right. What's in that triangle up there? What's the measure of each exterior angle? 120, 120, and 120. What do they add up to? 360. In this squarish rectangle-ish thing here, what's the measure of each exterior angle? 90, 90, 90, and 90. What do they add up to? 360. Do you see a pattern there? Yes. What do all exterior angles of any polygon add up to? 360. That's a fact that you need to know and remember. Okay. Properties of parallelograms. There's a whole bunch of them. One property of parallelograms is both pairs of opposite sides are parallel. Another property of parallelograms is both pairs of opposite sides are, besides being parallel, they are congruent. Another property of parallelograms is both pairs of opposite angles are, this angle is congruent with its opposite angle. This angle is congruent with its opposite angle. Another property of parallelograms is that consecutive angles are supplementary. Consecutive angles are supplementary. And the last one is the diagonals of a parallelogram bisect each other. Okay? Know your properties of a parallelogram. How do we solve that equation there? That proportion? Not by, well, sort of, kind of. How about we cross multiply when it's a proportion? Take 6 times 2x minus 3 equals 4 times x plus 4. So 12x minus 18 equals 4x plus 16. So what do we do to each side? Minus 4x. Then we 8x equals 34. So x equals 4.25? Am I right? I think I'm right. Okay. In this figure, what are some other things that I know besides angle B is congruent to angle D? What are some other things that I know? Not especially, because we didn't say that they're congruent figures. Oh, you are so smart, Nikita. You hit the nail on the head. Boom. They are parallel. Why are they parallel? Not just because they are. Because of something about B and D. What types of angles are B and D? Alternate interior angles. B and D are alternate interior angles, which makes those lines parallel. Another little tidbit, this angle is congruent to this angle because they're vertical angles. But the biggest one was, yeah, we have parallel lines there. All right, 2 points. You need 2 points to make a what? Line. It takes 2 points to make a line. It takes 3 non-collinear points to make a, oh, you would say triangle. More than a triangle. Makes it 2 dimensions. 2 dimensions. We have a point, we have a line, and we have a plane. It takes 3 non-collinear points to make a plane. So 1 point is just a point in space. 2 points make a line. It takes 3 non-collinear points. What does non-collinear mean? They're not on the same line. Yep. So 3 non-collinear points to make a plane. If both pairs of those lines are parallel, are we able to figure out what x is? Yes, we are. Because of corresponding angles. Because this angle corresponds to this angle, so what's this angle up here? 80. And this angle corresponds with this angle, so what do we do to solve for x? Set 4x minus 12 equal to 80. So 4x equals 92 divided by 4 divided by 4x equals 23. Okay, not so bad. Jack, just shut your lid so then you don't have that temptation. Thank you. All right, what's the perimeter of this little bad boy here? Some people say 44. Does that 45-degree angle have a hill of beans to do with anything about the perimeter on this one? No. No, it's just a parallelogram. Opposite sides are congruent in a parallelogram. So this adds up to 44. How do you find the area of this triangle? The area of a triangle, what's the formula? 1/2 the base times the height. What's the base on this triangle? 20. What's the height? 8. It is 80. How big is angle B? How big is angle C here in this triangle? How do you know C is 50? Because of the isosceles triangle theorem. The isosceles triangle theorem says if we have two congruent sides, then their opposite angles are congruent. So that must mean this is 50. So then, how many degrees is B? Why is it 80? Triangles angles always add up to 180 degrees. Okay. Triangle ABC is congruent, or is similar, not congruent. They're different sizes. So triangle ABC is similar to triangle DEF. How do I figure out what x is? They're similar triangles. How do I figure out what x is? Well, last time on the review, we said AB over something equals BC over something. AB over DE equals BC over. Do I know what AB is? 12. Do I know what DE is? Do I know what BC is? And EF? So then, how do I solve a proportion? Cross multiply. 12 times x equals 8 times 10 minus x. So 12x equals 80 minus 8x. What do I do to each side? Add 8x. So we get 20x equals 80. If we divide by 20, x equals 4. If we plug it in, that would make this 6 and this 4, 8 to 4, 12 to 6. Those are proportional. Which point on ray BF is not on segment BF? Which point on ray BF is not on segment BF? Is it A or is it G? Oh, okay, Jack. All right, Tucker. Uh-huh. So some of you say A, some of you say G. What I say about A is it's not on either one. A is not on Ray BF because Ray BF starts at B and goes through F and keeps going forever that direction. So G, G is a point that is on Ray BF, but not on segment BF because segment BF stops at B and stops at F. Imagine those angles are both right angles there. Then why is triangle ABD congruent to ACB? Those are right angles. Those are right triangles. Not quite, but you're in the ballpark. No, because when you say side-side angle, you make an angle side-side out of yourself, Tucker. So it's not side-side angle. But it's really a lot like side-side angle because there's two sides involved. It's just one of the sides has a really special name. Hypotenuse. Hypotenuse leg. The hypotenuse leg theorem says since AB is congruent to AB and the hypotenuse of each are congruent, then by hypotenuse leg, those are congruent to each other. This is a rectangle. What do we know about all rectangles? That their diagonals are congruent. Okay. Also, the diagonals are going to bisect each other. But besides the diagonals bisecting each other, we can say that AE plus EC equals AC. This is something from the early in the year, and I didn't cover it too much because this textbook doesn't cover it all that much, but it's still something I mentioned. Okay? That one little segment plus another little segment equals the whole segment. Do you remember what postulate that is? No. So this is why I review with you because, there was the angle addition postulate where two angles added up to each other made the whole angle. And this is the segment addition postulate, which is a small segment plus another small segment equals the whole segment. That's a segment addition postulate. Okay. If the volume of the sphere is 36 pi, what's the surface area of that sphere? Can I just go straight from volume to surface area? No, I have to find the what first so I can get from volume to surface area. I got to get to the radius. How in the heck am I going to get to the radius here? Well, I know the volume formula is 4/3 pi r cubed. What's the volume of this? 36 pi equals 4/3 pi r cubed. What's the first thing we can do to solve this? Cancel out the pies. We'll eat them pies. Yum, yum, yum. Then what do we do to each side? Multiply by 3/4 to cancel out the 4/3. So we get 27 equals r cubed. Then what do we do? What cubed equals 27? 3 cubed equals 27, right? So the radius must equal 3. What's my surface area formula? 4 pi r squared. So it's 4 times pi times 3 squared. So it's 4 times pi times 9, which is 36 pi. So is the radius or is the volume of a sphere always the same as the surface area of a sphere? No. The only time that they're the same is when it's 36 pi. That's the only time they're ever the same. Okay? So on the test, they will not be the same. Okay? They will not be the same. What is the circumference of a circle whose area is 49 pi? What's the circumference of a circle whose area is 49 pi? What do we have to do first? Area is pi r squared, right? So 49 pi equals pi r squared. What if you don't know a formula? What should you do? Look on the wall right over here. Okay. So if you sit over there, you might have to wander to this side of the room, and look at the wall. So your pies, what are we going to do with the pies? We're going to eat the pies, yeah. So r squared equals 49, so r equals 7. If r equals 7, what's the circumference? So it's 2 pi r. So it's 2 times pi times 7, or 14 pi. Now this one is a little trickier. To figure out this one, we want to figure out the perimeter. I got to figure out that slanted side. And the slanted side isn't like any of the other sides. So I got to do a little more math with that. Okay? What I'm going to do is I'm going to split up this figure. So if this is 8 here, this is 8 here. It's part of a what triangle? 45, 45, 90 triangle. So if this side's 8, this side's 8. If this is 10 up here, this is 10 down here. So I've got these 3 sides. I just got to get this slanty side. I could use the Pythagorean theorem if I wanted to, or I could just look on the wall over there to figure out what my missing side is. So what is the length of my hypotenuse going to be? X 8 square root of 2. Because it says x square root of 2 on the wall, but we know what x is. X is 8, so it's 8 square root of 2. So what's the perimeter? Well, you take 10 plus 8, which is 18, plus 10, which is 28, plus 8, which is 36. So it's 36 plus 8 square root of 2, and that's how the answer will look on the test. Something like that. It won't be in the decimal form. It'll be looking like that. Okay? This is a multiple choice test, so the nice thing about that is the answers are down there for you. What? This 8 we don't add because it's not part of the perimeter. It's not part of the outside. All right. Last one. What's the volume of that cylinder? What's the formula? Pi r squared h. Pi 5 squared 8. Pi times 25.